Hello everyone, my name is Sergio Tarazona. I'm from Whitestack and I'm also a TSC member. This is my first event in person, so I'm very happy to be part of this event. Today I'm going to talk about OSM as part of Telco Cloud footprint. So let's start. Okay, first the agenda. Today I'm going to talk about the Telco Cloud footprint using open technologies. Then I'm going to talk about OSM as part of Telco Cloud footprint. And finally, I will show you a short demo where we can see the OSM in action, deploying a 5G workload over Kubernetes clusters. First, we need to understand the requirements for the evolution of the telco clouds. I took this from Francisco Javier because I think this shows the main drivers that are leading us to the next gen telco cloud. So we have requirements from new services like 5G, the edge, fiber, IoT. Also, we have business drivers like cost reduction, time to market reduction, and improve the customer experience overall. Then we have the constraints like network and IT convergence. This process is taking some time, so this is a constraint right now. Then the legacy systems and legacy vertical deployments that probably most of all the operators have right now deployed. But at the same time, we have new technology enablers like containerization, cloud, autonomous operation, and COTS, where we can use any type of hardware to deploy any type of workload. So uh, those drivers are leading us to the next gen telco cloud. And telcos are moving from virtualization to cloudification. We can see here that both BNF, CNF vendors and operators are moving to cloudification, and they leverage the cloud itself, so they moving all their workloads to this cloudification approach. We see here many BNF, CNF vendors and also operators that are going to that way. Okay, now take a look of the Etsy NFB architecture. We have here this. This is known by all of you. You you know that there is an NFBI layer, virtualized infrastructure manager, BNF manager, NFBO orchestrator, OSS, and BNFs or CNFs with their respective EMS, and all the interfaces uh, that communicate each other. Okay, so open technologies can cover the key parts of this architecture. So in the NFBI layer, for example, we have KVM, it's part of Linux. It's widely used right now. At the virtualized infrastructure manager, we have OpenStack. For the OS BSS, we have tools like Grafana, Prometheus, Kibana, Elastic. And for the NFB orchestrator and BNF manager, we have open source MANO. But even for the BNFs or CNFs, we have open solutions. But in this case, we are not talk about them. We are just talk about all the remain solutions based on open technologies. Okay, so now we understand that we can cover all the layers in this CNFB architecture with open technologies. Okay, let's talk about Whitestack because we've been using these open technologies and we've been implementing telco clouds in Latin America since 2018, and we currently have more than 15 data centers in more than 6 countries, and all of these telco clouds are running both BNFs and CNFs. Okay, now let's talk about the biggest challenge that we're facing right now. Okay, so we want to move in from this, like this is like a vertical stack of any kind of uh, workload, telco workload. For example, we have 5G virtualization here for one provider with their own stack. We have another one for 4G virtualization with their own stack. We have a multi virtualization with its own stack, and for all type of workloads we have uh, each their own stack. Okay, so we want to move from this to this, where we have a unique telco cloud that it's distributed with any type of hardware, could be COTS or could be any. And on top of that, we have the BNFs or CNF, the applications itself, themselves. Sorry. So we have here the 5G core, for example, the PCRF, IMS, DRA, and so on. So this is a better approach because we have a unique telco cloud that it is managed by the operator. And on top of that, we have all the BNF, CNF vendors deploying their own applications. Okay, but the adoption of the telco cloud is a big challenge. That's why we suggest a progressive adoption. So we have like steps for this. This is the first step of the telco cloud adoption. In this first step, we suggest to start with virtualization of the BNFs using white cloud. In this case, is based on OpenStack. For software-defined storage, we suggest to use Ceph, and infrastructure management of all of these virtualization part using tools like Prometheus, Kibana, and Grafana, so on. So this is the basic step that any operator should take if they want to go to the telco cloud. After that, they can add more functionalities to or more features to this architecture, like CNF virtualization. In this case, we use Kubernetes. Network service orchestration, where we have open source MANO here, and also the fabric automation for the day 2 operations using ONOS, for example. So in this case, we have covered both CNF and BNF approach. They can work together in the same infrastructure. And the third and final step of the telco cloud adoption includes something like white portal, where we have a unified portal, automated backups, integration with Active Directory, IT orchestration, inventory, DNS, IPAM, CI/CD pipelines, RCA, hardware management, and we can see that we can cover most of all with open technologies, open tools, like we see, like we can see here uh, the alternatives that we can use for these parts. So, but obviously we have to live also with some proprietary solutions. In this case, maybe some backup is needed, and operator has their own solution, so we can integrate with that. Also with the firewalls that or load balancers that the operator already has. So in this case, we can build uh, most of the architecture with open technologies, but also we can use any solution that the operator already has. So let's talk about the benefits of using OSM. You already know all the benefits that uh, OSM can provide to the Telco Cloud. But in this case, in this specific case, we can define the descriptors once, and then we can use it in different data centers and different countries. So we just need to modify the instantiation parameters. For example, in this case, we can use OSM and have defined that SMSE, PCRF, or IMS descriptors. And once we have defined it, we can use it anywhere on top of any type of beam. In this case, if we use the same beam, we can define different sites to deploy specific workloads. In this case, for example, we have SMSE, IMS, and PCRF in this site 1, and we have IMS and PCRF in this site 2. So we can see here that we can leverage OSM to have descriptors defined once, and after that we can deploy it wherever we want. Okay, let's talk about the demo now. So in this case we have white NFB. This is an open source MANO product from Whitestack. We're going to use it to deploy 5G core, and this 5G core is divided in control plane and data plane. So for control plane, we use it as central data center, and for data plane, we use an edge data center. So all the core is from ONI. So we're going to use two NS and two KNFs. Both are instantiated using OSM. 5G core control plane has AMF, NRF, SMF, UDM, and the data plane includes UPF. In both cases, Whitecruiser has deployed the Kubernetes clusters. So let's move to the demo. Okay, so the first part, we're going to deploy the control plane, considering NRF, AMF, SMF, and UDR. So we're going to set up the name, then the description, then we'll select the NSD, the beam where we're going to deploy this, and finally the namespace. In this case we were typing it, but otherwise we have to use a config file. So here we can see the creation of the pods. Okay, the pods are being created. In this case, we're not talking about the details about the descriptors because we already did that in the previous presentation, so you can check there all the details about the descriptors for this 5G core. In this case, we just separate the control plane to the data plane. So we can see now that the pods we have some pods running, so we have to wait a little bit to have all of them in running status. Okay, that's it. Okay, now we see in the OSM that the network service is ready, and now we're going to deploy the data plane, which consists of UPF. In the same way that we did before, we're going to set the name. In this case is the data plane. We're going to select the proper NSD and the proper Beam account. Finally, we are going to define the namespace the same way we did before, but remember we have to use config file if we have more information in the instantiation. So we're going to check the pod status in the different in the other cluster. In this case is the edge cluster. So we're going to see, okay, it's ready. We have it running right now. So we're going back to the OSM and check that the network service is up and running. And that's it. We have our distributed 5G core ready. So we deploy it in two different sites, and this could be any country around the world. So that's it. Thank you very much. And if you have any question, please feel free to ask. Thanks.